Good evening, viewers. In today's class, we'll be talking about Bronsted and Lowry concept of acids and bases. The Bronsted and Lowry concept is proton-oriented concept. Any identity which is capable of proton donor, we call it an acid. Whereas any identity which can accept a proton, hence it is called as a base. To clarify this a little further, let me take an example. Ammonia molecule reacts with water to form. What are the ions present in water? H positive and OH minus. This H positive is accepted by ammonia due to the presence of lone pairs. Therefore, since ammonia is accepting a proton acceptor becomes a base. While when we talk about the water molecule, in this case, the water molecule is donating a proton. Proton is given away by water molecule. Hence, it is acting as a proton donor. Therefore, it is acting as acid according to the Bronsted and Lowry concept. After accepting a proton, ammonia becomes ammonium ion, while you are left with the hydroxyl ion in case of water. Now, moving ahead. After accepting ammonia, after accepting H positive ion, leads to the formation of ammonium, which according to you, what do you feel this should be? This can act as a proton donor or proton acceptor. Can this identity accept a proton? Never. Why so? Positive charge है ना? H positive इसके पास आ ही नहीं सकता. It would be repelled. So, NH4 positive can only act as a proton donor. Hence, this can only act as an acid, and this acidic identity is formed when a Bronsted and Lowry base has accepted a proton. So, when a base of Bronsted and Lowry concept accepts a proton, it starts acting like an acid and it is called as conjugate acid, representing it by a Ca. What about OH minus? What do you think this should act as? An acid or a base? Can it give off a proton? No. Can it attract a proton? Very well, yes. Proton is positively charged. OH minus is negatively charged. So a proton can easily attack onto a hydroxyl. This can act as a proton acceptor. Therefore, would be a basic identity formed after the loss of a proton from an acid. So when an acid loses a proton, it becomes a conjugate base. So this is your conjugate base. That is how we generate the conjugate bases from an acid and a conjugate acid from a base. Let me illustrate this a little more. Let me take an identity of the type water. Any identity, if you want it to form a conjugate base, what do you need to do? You need to remove a proton. And when you want it to form a conjugate acid, what do you want? You make it gain a proton. So your identity can transform into a conjugate base if you remove a proton, and can transform into a conjugate acid if you give it a proton. Coming to the first identity, water. If I want a conjugate base from water, I need to make it lose a proton. So this becomes the conjugate base. If I want a conjugate acid, you add a proton to it. On addition of a proton, this would become hydronium ion. Coming to the second example, I have the identity like this. To this identity, if I want to form a conjugate base, I need to remove a proton. If I make it lose a proton, I would be left with NH and there would be a 2 minus charge. And if I want a conjugate acid, I'll make it gain a proton. On gaining a proton, this NH2 will change to NH3. Proton is what charged? Positive. You already have a negative. So positive and negative would become neutral and you won't have any charge here. The third example is, I take ammonia as the example. Ammonia, after the loss of a proton, will lead to the formation of this identity, which would be conjugate base. Whereas if it accepts a proton, it would lead to the formation of your ammonium ion, which would be your conjugate acid. So all these are conjugate acids due to the gain of a proton, and all these are conjugate bases due to the loss of a proton. The last identity is a bisulfate ion. This bisulfate ion can transform into a base by loss of a proton, leading to the formation of a sulfate, and it can also transform into a conjugate acid by gaining a proton. We become H2 because you have a proton to add. SO4 proton would be positive. Your bisulfate is negative, hence no charge in the identity. So you need to make a conjugate base, a conjugate acid. Acid according to Bronsted and Lowry concept is a proton donor, and a base according to Bronsted and Lowry concept becomes a proton acceptor, as we initially did. So all concepts of Bronsted and Lowry are related to a proton, where a proton, if is accepted, such an identity is called basis. If it can be donated, such an identity is called as an acid. Thanks.